Assalamualaikum and hello everyone. Welcome back to the second video of 2.1 Bohr's atomic model. Okay, so here's actually all the learning outcomes. Sebenarnya, once we have untuk page 1 and 2 ni, actually we have done yang A, B, C ni. Actually, of these four postulates that we have learned, it describes the formation of line spectrum of hydrogen atom. Again, for the case of Bohr's atomic model, it actually only applies for the one electron atom. One electron atom tu specifically hydrogen lah. If you look back at your list of constant, kita tengok hydrogen, number of proton dia 1. Electron dia pun 1. Tapi no worries, yang ini kita akan tengok lagi sekali. Okay, and then actually we have learned this part. Calculate the energy change of electron during transition. Inilah. As I've mentioned before, ikut kamu mana yang kamu selesa. Yang misalnya guna example is final minus initial kan. Remember, final minus initial tu mesti yang when the electron drop. Initial minus final. Oh, okay. Initial minus final. This is actually when postulate 4, when the electron drops tu. Ataupun you can use N1 minus yang N2. Make sure N1 tu is bigger than N2. Okay. Okay, so in this video, what we're going to look at is actually calculate the photon of energy emitted by an electron that produces particular wavelength during transition. Okay. So let's look on your notes. It will be on page 3. Okay, so here it mentioned about the amount of energy released by the electron is called an energy of photon. So, kita kata, actually, bila energy is released from the excited state ataupun higher energy level to the ground state ataupun lower energy level, energy is released in the form of light ataupun energy is released in the form of photon. So, kat sini bagi tahulah, mention here, the amount of energy released is called an energy of photon, and that energy actually is emitted ataupun produced in the form of radiation with appropriate frequency and wavelength. So actually from the delta E itself, kita boleh calculate the wavelength ataupun the frequency itself. Okay. So delta E is equal to H, which is your Planck constant, times frequency. Okay, so here, H is your Planck constant, 6.363 exponent negative 34 joule second. Okay, so no worries there, you don't have to memorize, it's actually on the list of constant. Okay, kalau kita tak ingat list of constant yang mana satu, sebenarnya yang inilah. Mana tadi kita tengok ni, Planck constant. Ataupun kamu boleh ambil this one ataupun 6.63 pun boleh juga. Okay, tapi yang tadi kita ada belajar tu yang Rydberg constant kan? Rydberg constant kat sini. Rydberg constant ada dua. Setakat ni yang kita belajar is this one, 2.18 exponent negative 18. Okay. Okay, back to our notes here. Okay, and then V is your frequency. Frequency unit dia apa? Unit dia adalah per second. So make sure the unit of frequency is per second. Usually dia membagilah. Okay, and then we know that actually, alah, yang ini nampak tak cantik pula. Tulislah kat tepi. Tulislah kat tepi this one. V equal to C over lambda, where C is your speed of light, 3 exponent 8 meter per second, divided by wavelength. So it means that when dekat sini unit dia mesti include lah. C is meter per second. So here wavelength unit dia adalah meter. So your frequency is per second. Okay. And then when we substitute frequency equal to C over lambda, in this equation we will get E equal to HC over lambda. Okay, so setakat ni macam jumpa macam fizik balik kan. Tapi make sure there are, so far you have include these 3. 1, 2, 3. Ada 2 lagi formula yang kamu kena ingat. This one, delta E ni dengan yang the energy, this one. Okay, this is all the formula that you have to memorize so far. Okay. Okay, so right now kita dah tahu macam mana dah nak calculate delta E from the previous postulate 4. Okay, from that delta E we can calculate our frequency and wavelength. So let's look at the examples. Okay, now let's look for example number 1. So for example number 1, dia kata electron from 5th energy level to 2nd energy level. So I'm just going to draw it here. So the electron is actually dia moving down kan, dia fall back. Dia fall from the high energy level ataupun excited state to ground state. So excited kita n equal to 5, ground kita n equal to 2. So dia calculate energy of electron before it drops. So maknanya dia nak before it drops lagi. So originally dia dekat n equal to 5. So which one formula going to use? This is actually the energy difference. So kita nak guna energy difference. Kita nak calculate the specific pada n equal to 5. We're going to use the formula from the second postulate. So here I'm just going to write down the formula back. Okay, so n kita remember before it drops, before dia jatuh tu dia dekat tingkat 5. Dia baru kat tingkat 5 n equal to 5. So I'm just gonna substitute the values. Remember for E ni memang ada negative tu. So we do get this value. So that's for example A. So example B, the energy of photon emitted. Dia minta calculate this one. So this is actually the same as the energy difference ataupun the energy release when the electron drop. Okay, so nak tahu what is the energy ni. So we're going to use this formula. So up to you, initial minus final ataupun 1 minus 2 where 1 must be bigger than 2. Okay, so here initial kita, final kita which one? Okay, so when we look back pada kita punya lukisan, initial kita is when n equal to 5. So here write down this is initial, n equal to is our final. Okay, so just gonna substitute the same RH 2.18 exponent negative 18. Initial kita is, if you don't want to draw the energy level, just write down kat sini pun tak apa, 5. Final kita 2 when it drops to 2. Okay, so kita boleh calculate terus. So we know that our delta E is equal to negative 4.58 exponent negative 19. So that's for question A dengan B. So for question A ni, the specific n. Tapi kat sini formula lain sikit, ada negative. Negative tu it means that there is attraction. Okay, for energy difference, even though in the formula no negative sign, but the final answer we still get negative value because energy is released. When electron fall back, dia drop to lower state, dia akan release the energy. So that's for the case of an electron. Question C, dia nak when 1 mole of electron drops. Okay, ni question A and B specifically for 1 electron. Here is actually for 1 mole. So how to calculate this? Okay, so masih lagi sama. We're going to look at our delta E. Tapi 1 mole of electron is equal to 6.02 exponent 23. This is actually based on your Avogadro constant. It's 6.02 exponent negative 23 atoms. Itulah. Okay, so we know that for our delta E, the energy of photon emitted, okay, bila dia when it's only 1 electron, this is the value. Okay, but then this one kita nak 1 mole kan, so multiply by our Avogadro constant. So when we multiply this value, we will get 275,716 joule per mole. Okay, so joule ni is actually from our energy. Kenapa pula ada mole ni? Sebab kita kata per 1 mole. So kita kena buat lah 1 mole memang macam 100 km per hour. So what does it mean 100 km per hour? Maknanya in an hour, speed limit kita 100 km kan? Macam tu lah. So paling penting kena ada per mole. Okay, but why is this the answer kat sini dia bagi in kilojoule per mole? Remember, kilo maknanya is actually exponent 3. So I'm just going to rearrange it to get exponent 3. Okay, so terus simplifykan jadi kilojoule per mole. Okay, so that's for question C. Yang ni yang lain sikit. Tiba dia minta untuk 1 mole of electron. When the question asks for 1 mole, times kan energy of photon tu, times kan Avogadro. Remember, unit dia ada per mole. Sekarang ni the frequency of photon emitted is actually based on, for the case of 1 electron lah. Okay. Frequency symbol dia adalah V. So from the formula itself, we know that delta E is equal to HV. Okay, delta E ni kita akan guna for yang case 1 electron, which is 4.58 exponent negative 19. Okay, so negative ni energy is released. Tapi bila calculation for the case of frequency dengan wavelength, jangan include the negative sign. Kita mesti include kan. Yang ini just make sure write down in your notes. It's very important. For calculation of photon and wavelength, do not include our negative sign. Okay. Negative sign tu untuk delta E. Okay. Yang ini nak kata emphasize sangat kan. Do not. Okay. So, Y nanti kita akan tengok. Okay. H ni, dalam case ni is our Planck's constant. 6.63 exponent negative 34. Okay. And then, times by frequency, which is our unknown. So, we get this value. So, frequency unit dia lah per second. Okay. So, why we do not include the sign? Okay. Sebab, okay. Planck constant is a positive value. Frequency pun it must be in positive value. Frequency mana ada negative sign. Kalau saya tanya lecture fizik kamu. So that's why delta E must be in positive. So dalam case ni sebab apa? Sebab our frequency and wavelength must be positive value. So sebab itulah energy pun kita kena guna the positive value. So contohnya kalau length mana ada negative 0.1 meter ke apa kan? Tidak ada. Samalah case of frequency. So that's why delta E jadi positif. Tapi kalau dalam case yang delta E yang biasa dengan energy tu kena buatlah negative sign. Okay. So kalau negative sign kamu tambah kat sini salah. Tapi kalau energy of photon emitted ataupun before it drops kena letak. Example tu I believe you could try it yourself.